Welcome folks. In this video we are going to focus on science paper 1 for the year 2012. Now we have a question before us, which is question 1. Figure 1.1 below shows part of a vernier calipers used to measure a physical quantity. Now we have been given the structure of a vernier calipers. Now Roman number 1, what is the reading shown above on the vernier caliper? So what are we supposed to do? We are first going to find the main scale. After the main scale, we are supposed to find the vernier scale. Now, how do you find the readings in the main scale? So in the main scale, we need to look at the mark before the 0 on the vernier scale. So now, before we do that, let's identify the main scale. So the above here is our main scale. Then we have our vernier scale here. Then the mark that we are looking at is the first mark on the left side of the 0. So the 0 line we are looking at is here. So the first line is this point. This mark here is our point of consideration. Now, if you look at the number, we only have the number 4 on the right side. So what are we supposed to do given the number on the right side and we want the mark on the left side? So we will start by counting down. Instead of counting up, we'll start by counting down. Now, so what we are going to do is we can, if this is given in centimeters, we can take it in millimeters or in centimeters, depends. So let's say we want to take it in millimeters. So 4 centimeters in millimeters is 40 centimeters. You just multiply by 10. So if this is 40, this is 39, then this is 38, then our line of consideration is 37 millimeters. So that is our main scale, 37 millimeters. Then if you want to give it in centimeters, 37 you divide by 10, you get 3.7. Then after that, we move on to vernier scale. Under the vernier scale, we are going to look at the graduation mark, the one that lines exactly with the main scale and the vernier scale. So which line is that? So if you look at the line, is this one. This is the mark that lines the main scale with the vernier scale. So on which position is this one? So we say 1, 2, 3. So this is on position number 3. Now, depending on the units that you want your answers to be in, if you are taking your answers like the one that I'm using in millimeters, this number should be multiplied by 0.1. So 3 times 0.1, we get 0.3 millimeters. Then after that, you just have to find the sum of the readings for the main scale and the vernier scale. So let's say 37 plus 0.3, so I'm getting 37.3 millimeters. So this is our final answer for the first part. We move on to Roman number 2. What physical quantity does the vernier calipers measure? So this is length. So that's the answer that you're supposed to give here. State 2 precautions that must be taken when taking measurements using a micrometer screw gauge. So the first one, we can say by zeroing the instrument. So this means that before we do any measurements, we are supposed to make sure that the readings must be 0. Then the second precaution that we can do here is we need to clean. So by cleaning the angle and the spindle. Why are we cleaning this? Because it is the position in between the angle and the spindle is where the object that you're trying to measure its length is placed. So we need to make sure that it's thoroughly cleaned, because if you look at the micrometer screw gauge, it is very accurate in such a way that it can even measure the length of a dust particle. So in order to prevent the readings of that particle with the reading of the objects that we are trying to find, we need to make sure that it has to be cleaned. We have question 2. Figure 2.1 shows a velocity time graph of an object moving along a straight road. Okay, so before we do some answers, let's put some points, some letters. So we'll say this is our A. Now this point is simply means the rest position, and whenever we have the rest position, the initial velocity is 0, the acceleration is also 0. Then at point B, we'll consider this one as our final velocity for the first part. Then point C, if you look at B and C, the line is straight and it is parallel to the x-axis. Here we have constant velocity, so at this point an object or a car is moving with a constant velocity. Now for the first part, since we have a linear line, this is constant acceleration. Then for the last part, this point C becomes the initial of the last part. Then this point becomes the final. Now the initial of the last part will be this number here on the y-axis, which is 10 meters per second. Then for the final, here is 0. Please never confuse 50 to be the final velocity. No, the final velocity is always taken from the y-axis. So if we move in this line, it will give us a 0. So that's what we need to look at here. Now let's look at the questions that was the first question. What is the total time for the whole journey? Total time for the whole journey is 50 seconds. Because the completion of the journey was at point D, and the time at point D is 50 seconds. Then what is the maximum velocity for the journey? So the maximum velocity must be taken in the y-axis. So if we look at the velocity that we have, the first velocity was 0 when it was at rest, then 5, 10. So it never exceeded 10. We can see that the highest point reached by our graph is 10. So this is our highest velocity, so 10 meters per second. Then what is the acceleration during the first part of the journey? So the acceleration is given by final minus initial divided by time. The final velocity is 10, which is the highest point for the first part. The initial is 0 since it started from rest. Then the time taken is also 10. You can see here, this is our 10 here. So 10 minus 0 over 10, 10 into 10 is 1 meter per second squared. Then we go to question D, calculate the total distance covered by the car. So the total distance, we are dealing with a trapezium. So we are supposed to use the formula for the area for the trapezium. And I'm sure by now we have some ideas on how do we apply this formula. Okay, so the formula for this part is this one. Distance is equal to half, then the sum of A and B multiplied by the height. Now how do we get these values? So the value of A is the one on top, this part here. From here up to here is the value of A. Now if you can look at where A is, we don't have the number, so we need to go in the x-axis is where we are going to get the numbers. So if we move down here, so I'm getting 20, then here 40. So I need to find the difference between 40 and 20, which is, if you want, we can just say from here it's 10, another 10, which is 20, or 40 minus 20 is 20. So the value of A is 20. Then for the value of B is this line, the whole line from here up to 0, which is B is equal to 50. Then what of our height? So our height is this line from the horizontal x-axis up to the highest velocity achieved by the car, which is 10. So we have the whole information. We can now just go back to our question. So say distance is equal to half a plus b multiplied by height. So the distance is half. What is the value of a? We said 20 plus b is 50 multiplied by 10. So 2 here is 1, 2 here is 5. Then if we add these two numbers, we get 70 multiplied by 5. So how do we multiply these numbers? We can just multiply 7 times 5, giving us 35, then add a 0. So the total distance traveled under the given graph is 350 meters. We move on to question 3. Figure 3.1 shows an object of mass 0.7 kilograms resting on a horizontal surface. So we have two forces pointing in two different directions, which simply means that there are two, we can give an example, two people that were trying to pull. They are pulling against each other. Then the only difference was the amount of force applied here. Then question, if the object is pulled to the left by a force of 6.0 newtons and to the right by a force of 2.5 newtons, and assuming that no other forces acting on the object. So this assumption here is that we are assuming that also there is no friction. We know that the friction is just the force that opposes motion, and we are assuming that we do not have such a force. Calculate the first one. We want to find the resultant force. So the resultant force is also known as net force. So how do we find the net force? So net force can be calculated by, we need to find the difference between these two forces because they are pointing in opposite direction. So whenever you have two forces pointing in opposite direction, you need to do a subtraction, or if you want, you can just use the x-axis. So we know that if you move to the left of the x-axis, the numbers decreasing. Then if you move to the right, the numbers increases. So we have to do some subtraction. So we'll say 6.0 newtons minus 2.5 newtons. I'm sure this will give us 3.5 newtons as our net force. So this is our resultant force that we need. Now we move on to question 2. The acceleration produced by the resultant force in 1. So whenever a force applied on an object is greater than let's say the friction force is, for instance, we have the friction force. If that force is greater than that, then that object must accelerate. So for acceleration to be produced, there should be a certain amount of force that should be exerted on that particular object. Now, for this question, you are not supposed to use the one that we use under the velocity time graph. That one is used whenever you are given the initial velocity, final velocity, and time. But whenever you are given the mass and you have the net force, the formula that you are supposed to use is this one. So net force is equal to mass multiplied by the acceleration. Then we divide by m, also here by m, so that acceleration is equal to net force over the mass. Then the net force is 3.5. The mass, remember, is 0.7. So you just have to do some math here. So 3.5 divided by 0.7. So my final answer is 5 meters per second squared. So which simply means that if we have an object, the one given, and a force of 3.5, which is the net force, is applied, then this object of mass 0.7 kg will produce an acceleration of 5 meters per second squared. Then we move on to question B. Explain why in practice the actual acceleration for the object may be lower than your answer to A1. So the acceleration depends on the net force. So in practical, in an actual situation, there should be the force of friction that is opposing that motion. And because of the presence of the force of friction, then we would find that instead of getting 3.5 as our net force, we may get a net force less than this, because there is another force which is opposing this motion. So we'll say because there is a force of friction which opposes motion. So that's the reason why in the actual, okay, so which opposes motion. So we have been given the answer. Then we move on to question 4. Define work and power. So if you just look at the work, energy and power, these three factors are related to each other. The first one, we know that energy is defined as the ability to do work. So for someone to do work, energy must be there. Now, for work to be done, there should be a certain amount of force that should be produced. That's why some of the textbooks may give you the definition for work as the transfer of energy. For example, if this is a ball and someone kicks this ball, there is a force produced by the foot, then this force will have a certain amount of energy, and this energy must be transferred on this ball, and for this ball to move, there should be the energy that is being transferred from the foot into this. So that's why we are saying whenever our work is done, or if you look at just work is all about the transfer of energy from one object onto another object. So that's what we can say work. But we are going to define work according to the level that we are looking at here. So we just say this is the force multiplied by the distance moved in the direction of the force. Okay, so the other thing that we can share under this one is that if let's say we have a box here and someone is putting this box to the right with, let's say, 10 newtons, and this box covered a distance of 15 meters. If this is our distance of 15 meters, then the work done is this times this. Now what happens if maybe the force is in this direction, but the direction displacement covered is this. So whenever we have two arrows pointing in opposite direction, then the work done on that particular object is negative. So we have a positive work done if the force is pointing in the same displacement covered. Then for a case where, let's say this is our object, the distance, the direction of the displacement is in this direction, which is to the right, then the force being applied, we can say, is perpendicular. So if the force applied is perpendicular to the distance covered, making perpendicular simply means making an angle of 90, then the work done is 0, because work done is equal to force times distance cos c multiplied by cos theta. So we know that cos 90 will give you a 0. So to summarize the point here, we are saying that whenever the force applied is perpendicular to the displacement, then there is no work done. According to physics, there is no work done. So for you to do the work, the force must be in the same direction as the distance, or maybe in the opposite direction, but there should be an angle of 180 or 0 for you to do the work. Then what of power? So power is just defined as, we'll say this is the rate of doing work. We move on to question B. A pupil of mass 50 kg runs up a flight of 20 stairs, each 25 centimeter high in a time of 20 seconds. Calculate the first one, the pupils gaining potential energy. So potential energy is given by mass multiplied by gravity times the height. Mass is given, gravity is given, we just need to find the height. Now, since there are 20 stairs, then each is 25. To find the total length of the 20 stairs, we are supposed to multiply 20 times 25. So of which you are getting a 500 centimeters. So that is the total length for the all 20 stairs. Now remember, whenever you are using you're trying to find potential energy, make sure the distance is in meters. So there is a need of converting centimeters into meters. So how do you do that? So you need to remember that 1 meter is equivalent to 100 centimeters. Never confuse this with a 1000. You only use 1000 if the prefix of the particular word has a kilo. Like a kilograms is 1000, kilowatts is 1000, kilohertz is 1000. Now for this one, 1 meter is equal to 100 centimeters. So if we are multiplying from meters to centimeter, remember to multiply by 100. Then the reverse, you have to divide by 100. So to find the distance in meters, we just have to divide by 100. So we have our distance in meters. So we can now find potential energy, which is our mass is 50 kg, gravity is 10, then our height is 5. So if we multiply 50 times 10 is 500. 500 times 5, we get 2500 joules as our final answer. Then for Roman number 2, the use of power developed by the pupil in climbing the stairs. So power is work done divided by time. So work done is our potential energy. Why do we say so? Because remember we said work done is just the product of the force and the distance. So it's force times the distance. Now if you look at the work done against gravity, where there is F, we can replace with what? With mg. Why? Mg is the formula for weight, which is force against to gravity. So we can put mg. Then where there is d, since we are moving against gravity, which is height, we can use h. So the work done for something that is moving against gravity is the same as the potential energy. So that is the number that we are going to use, which is 2500 divided by, then the seconds given were 20 seconds. So we divide by 20 seconds. So if you divide by 20 seconds, I'm getting 125 watts. Okay, we move on to question 5. So under question 5, we have been given a laboratory thermometer with some of the parts here. Okay, so we have this one. So name the substance labeled A. So since we are dealing with a laboratory, this is alcohol. Then for question B, name the section labeled B. So we have a capillary tube. Then why is part B narrow? So why is part B narrow? We say for easy penetration of heat, so that it can penetrate easily. Then explain why the wall of the thermometer bulb marked D is thin. So say to conduct heat easily. Then for question, give two advantages of a thermocouple thermometer compared with a mercury thermometer for measuring temperature. So the first one, thermocouple. Can measure a very high temperature. Then a thermocouple is durable. Durable, it means it can last long. Then we have question 6. So under question 6, we are told the light and gamma rays are both examples of electromagnetic radiation. So electromagnetic radiation, which is we have the electromagnetic spectrum where we are given a series of these radiation. Now there are differences and also similarities among these radiations. Like if you look at the similarities, we are looking at, if you look at the similarities, we may look at in terms of speed. They all travel at the same speed of light. Then if you look at in terms of passing through a vacuum, they can all pass through a vacuum, then they all carry energy, they are all transverse waves. Then now let's look at the questions that were given. So the questions that were given, the first one, name two other types of electromagnetic radiation. So based on the one that we are given, we are told to give two others. So we can say, we can give X-rays. We can use the ultraviolet, radio waves, okay, even infrared if you want. Then state two differences between light and gamma rays. So the first difference that we are going to look at is that gamma rays have the highest energy than this one. So say gamma rays have high, so say higher energy than light. Then the second difference we can give in terms of wavelength. So gamma rays have shorter wavelength than light. Okay, we move on to question B. So under question B, the speed of light is 3 times 10 raised to the power 8 meters per second. Calculate the frequency of yellow light of wavelength that. So we have the formula: speed is equal to frequency multiplied by wavelength. So over wavelength over wavelength. So if we want frequency, we need to have the speed divided by the wavelength. So what's our speed? 3 times 10 raised to the power 8 over, what's our wavelength? 6 times 10 raised to the power negative 7 meters. And whenever you are carrying out this type of calculations, please make sure you use the brackets. So 3 times 10 raised to the power 8 divided by 6 times 10 to the power negative 7. So my final answer I'm getting is about 5 times 10 raised to the power 14, since its frequency is what? Hertz. Move on to question 7. Figure 7.1 shows a ray of light from air to water. The diagram is not drawn to scale. The first one, determine the angle of incidence. So where is the angle of incidence? It is between the normal ray and the incident ray. So this is our incident ray. So this angle here is the angle that we are looking for. Now remember, the angle between the normal ray and the surface is always 90. So if this angle is 90 and we have given 20, we need to subtract 20 from 90, we get the angle that we want. So 90 minus 20 will give us 70. So here there is a 70. Then what else? What else? The angle of refraction. So this is our refracted ray. So this angle here is the angle of refraction. So how can we find this angle of refraction? Remember, this angle is equal to 90 and this angle is equal to 131. So we are going to subtract 90 from 131, then we have this remaining part here. So we have 131 minus 90. So I'm getting 41. Okay, then our question B, calculate the refractive index. So refractive index is equal to sine I over sine R. So sine 70 divided by sine 41. Okay, so sine 40 divided by, sorry, not 40, sine 70 divided by sine 41. So I'm getting about 1.43. And remember, this is a ratio, so you don't have to put the units. We'll move on to question 8. Figure 8.1 shows a boat which uses ultrasonic sound to calculate the depth of the sea. Okay, the speed of sound in water is 1,400 meters per second, and an ultrasound wave has a frequency of this, which is 28,000 hertz. Okay, calculate the wavelength of the ultrasound in water. So we have the speed, and this also speed is equal to frequency multiplied by wavelength. So over frequency over frequency. So wavelength is equal to velocity, which is speed, divided by frequency. What is the speed? Is this number 1,400 over the frequency is this number, 28,000. So 1,400 divided by 28,000, getting 0.05. So 0.05 meters. So this is the answer. Then B, the pulse takes 0.2 seconds to travel from the transmitter to seabed and back to the detector. Calculate the distance to the seabed. So the concept that we are supposed to use here is that we are going to use the principle of an echo. So this here must bounce to the seabed, then back to this point here. So the formula that we are supposed to use is this formula here. So say speed is equal to 2 times distance over time. So what is the speed? Speed is given. The speed is given is 1,400. Is 1,400. 2d over time 0.2 seconds over 1, we cross multiply. So 1,400 times 0.2, I'm getting 280. So this 280 meters is the distance of going and also coming back. Now we only need one of these, so we divide by 2. Also here by 2, which is distance is equal to 140 meters. So this is our distance, which simply means the going covered the 140 meters and the coming back also 140 meters. Then the total distance covered, since it's an echo principle, is 280 meters. Then we have our last question, question 9. Figure 9.1 shows a simple transformer which can be used to light a bulb. The bulb is labeled. So when the main supply is switched on, the bulb is very bright. So state one way in which the potential difference across the bulb can be decreased without changing the main supply. So we are saying the main supply, we want it to remain 240, but the output voltage, we want it to be decreased. So how can we make this one? So what we are supposed to do is, we know that the principle of transformer, it all depends on the number of turns on the number of turns on the primary coil with respect the number of turns on the secondary coil. So depends on where you want the voltage to be greater or smaller. So since our case is, we want the voltage on the secondary coil to be small or smaller than the one produced, or maybe want to decrease. So what we are going to do is, we are going to reduce the number of coils, so the number of turns on the secondary coil. So say by reducing the number of turns on the secondary coil. So once that is done, then there is a reduction of voltage. For B, for the lamp operating at the correct brightness, calculate, remember, the current in the secondary coil. So let's see what we have. So from the data on the secondary coil, we have voltage, then power. So which formula can we use to calculate current given voltage and power? We use this formula. Power is equal to voltage multiplied by current, so over V. So current is equal to power divided by voltage. So what's our power? 36 watts over 24 volts. So this should be 1.5. So 36 divided by 24. So yes, it's 1.5 amps. So that's the current on the secondary coil. Remember, to the current in the primary coil, assume that the transformer is 100% efficient. So this one is power on the primary must be equal to power on the secondary. So that's a principle. Then we know that power is equal to voltage times current. So voltage on the primary coil times current on the primary coil must be equal to voltage on the secondary coil times current on the secondary coil. So this is a formula that you're supposed to use if there is no energy loss or the transformer is 100. So voltage on the primary coil is 240. Okay, so we have 240 volts times IP. Voltage on the secondary is 24 volts times the current. The current is 1.5 amps. So over 240 over 240 over 2 volts. So we cancel this. We have IP is equal to, so this we know here is 1, here is 10. So 1.5 divided by 10 is 0.15. So our current on the primary coil is 0.15. Or if you want, we can say we know that the formula for power is voltage times current, so we can say Vp times Ip is equal to, then what did we say the power? The power is given is 36. So if you don't want to do this, you can just use 36 since we are given. So you know that the power, the voltage on the primary coil is 240 times Ip is equal to 36 over 240 over 240. So what is IP? 36 divided by 240. I'm getting 0.15. So we are getting the same answer. Amps. So this is how we can do some calculations. Now to analyze what was happening, let's look at voltage. The voltage on the primary is 240 volts. Then the voltage on the secondary is 24 volts. So this simply means that this is a step down transform. Now let's say we don't want to use the formula, we can look at by what number can we divide 240 with to give us 24. So in order to check, we can just say 240 over 24 is giving us what? 10. So this simply means that in this number they divided a 10. 10 into 240 is 24. So the same number can be used to find the current. If current on the secondary is 1.5 amps and we want to find the current on the primary, we just have to divide by 10. So 1.5 divided by 10 will give us 0.15. Now you need to look at this. If the voltage on the primary is greater than voltage on the secondary, then for current it will be opposite. The current on the secondary must be greater than the current on the primary. So this is what we can say. So that's it for this video. Thanks for watching.